In this video, we'll review right triangle trigonometry. To begin, let's talk about some vocabulary for our right triangle here. To begin with, let's classify the largest side. Side AB is known as the hypotenuse. The longest side, or the one opposite the right angle in a right triangle, is always known as the hypotenuse. The other two sides will be referred to as legs in right triangles. Let's classify the legs. If we're standing at angle A, we call that the reference angle. The side that is nearest our reference angle is known as the adjacent leg. The adjacent leg is the one that is nearest to your angle, which makes the other one, the one that is opposite from our angle, the opposite leg. Segment BC is opposite of angle A, so it's the opposite leg. Now we have two acute angles here, angles A and B. Depending on which angle you're using, that's going to change up which one is the opposite and which one's the adjacent leg. So now, let's change our reference angle. Instead, imagine we're now standing at angle B. If I stand at angle B, the hypotenuse is still AB, but now BC is the adjacent leg because it's next to my reference angle, and AC is now my opposite leg because it's on the opposite side of the triangle from angle B. So when we're doing our trig problems, we're going to have to know these three terms: which one's opposite, which is adjacent, and which is hypotenuse. Before we do trig ratios, let's talk about what a ratio is. A ratio is just a comparison of two numbers written as a fraction. Now, certain ratios for right triangles are going to be given specific names. And let's talk about those three ratios. They're sine, cosine, and tangent. To begin, let's define tangent. Tangent is the ratio of the opposite to the adjacent legs. The next trig function we're going to look at is sine. Sine is the ratio of opposite to the hypotenuse. The last one will be cosine. Cosine is the ratio of adjacent to hypotenuse. So our three trig functions again are tangent, sine, and cosine. Now there's a trick to memorize which one's sine, which one's cosine, and which one's tangent. And it goes like this. Most people are going to remember a little trick. If you've ever been out barefoot walking around and you stubbed your toe and you scrape the skin off, it really, really hurts. So you really want, the first thing you want to do when that toe really hurts, you want to get there and soak it in some water to make it feel better. So if you remember this little phrase, soak a toe. If you stub your toe and you want to stick it in the water, you're going to go, ah, that feels better. And this soak a toe is going to how I'm going to remember the trig functions. Now it seems kind of silly, but trust me, this works. Here's how it works. The first part, so, is the ratio of sine, which is opposite to hypotenuse. The ca is cosine, which is adjacent to hypotenuse. And the toa, well, that's tangent. Tangent is opposite to adjacent. So when you stub that toe, you want to soak a toe and go, ah. So there's my trig functions. Sine, opposite to hypotenuse. Cosine, adjacent to hypotenuse. And tangent, opposite to adjacent. Now again, it seems kind of silly, but trust me, it works. When you do a test or a quiz, the first thing I'd write on it would be that SOHCAHTOA to help you remember which one's sine, which one's cosine, and which one's tangent. So let's look at some examples of these now. To begin, let's take a look at this first triangle. In the first triangle, I have a 31-degree angle, and I have a side x and another side 10. Before I set up a trig function, the first thing I want to figure out is, what are my sides that I'm giving? So I'm going to look. I know that in this triangle, the 10 is opposite the right angle. That's going to make that the hypotenuse. So I'm going to go ahead and label that. The x is away from the 31-degree angle. The leg that is opposite of the 31-degree angle is known as my opposite leg. So I'm going to label that an O. And then I'm going to go back to SOHCAHTOA and figure out which trig function has O and H. Sine is opposite to hypotenuse, so this is going to be a sine function. In sine, the sine of the angle equals opposite over the hypotenuse. The opposite in this case is x, and the hypotenuse is 10. So when I set this one up, it's going to be sine of 31 degrees equals x over 10. Now it's not magic that x is on top. The opposite in the sine function should be on top. In this case, opposite is x, so x goes on top here. To solve the problem for x, I'm going to have to get rid of the 10. Right now this is x divided by 10. The opposite of dividing is multiplying, so I'll multiply both sides by 10. And I get x equals 10 sine of 31. Now I grab my calculator, make sure it's in degree mode, and type it in. 10 times sine of 31, and I'm going to round it. It's going to turn out to be about 5.15 units. Now take a look at the next problem. Figure out which pieces of the triangle you're given and which trig function you'd want to use here. In this problem, I'm looking at it, and I see that we have the side that is 27, which is opposite the right angle. Because it's opposite the right angle, that's going to be the hypotenuse. The x, in this case, is next to the 40-degree angle, which makes that the adjacent leg. So I have a and h. The trig function that has a and h is cosine, so we'll set this up using cosine of 40 degrees, equals the adjacent, which in this case is x, over the hypotenuse, which is 27. So we'll get the cosine of 40 degrees equals x over 27. To solve for x, we'll multiply both sides by 27, and we'll get x equals 27 cosine of 40 degrees. Type it on the calculator, 27 times cosine 40, and it equals, we'll see that it rounds to about 20.68 meters. Now when you do these problems, make sure you watch the units. You want to use the same units that are given, so in problem 2 we're using meters. In problem 1 we didn't have a unit, so we just used the generic U. So let's try 2 more examples. This time, I want you to work it out on your own, pause the video, and when you're ready, resume it to check your answers. Here you go. Now hopefully you've had a chance to work these out. In problem 3, I see that we don't have the hypotenuse listed here. The hypotenuse, the one that's opposite the right angle, is blank. So this is kind of an indicator that I'm going to be using tangent. The other trig functions don't have hypotenuse. The other trig functions do have hypotenuse. Tangent is the only one that doesn't. So looking at this, 26 degrees, opposite that would be x, and adjacent to it would be 4. So x is my opposite, and 4 is my adjacent. Tangent is opposite to adjacent, so I'll be using tangent. In this case, tangent of 26 degrees equals x over 4. I want to solve for x, so I'll multiply both sides by 4, and I'll get x equals 4 tangent of 26 degrees. Take my calculator, type it in, 4 times tangent of 26, and hit enter, and I'll see that it rounds to about 1.95 inches. In the next problem, this time I do have the hypotenuse. X is away from the right angle, so x is the hypotenuse. 37 degrees is my acute angle, and the 500 is near it. That makes the 500 kilometer piece my adjacent leg. The trig function that has a and h is cosine. So when I set this one up, I'll say cosine of 37 degrees equals the adjacent over the hypotenuse, but this time the adjacent is the 500, and x is the hypotenuse. So now x is on the bottom, because in cosine, the hypotenuse should be on the bottom. Now this problem is going to be a little bit trickier to solve. We'll start by multiplying both sides by x. This will give me x cosine of 37 degrees equals 500. Dividing both sides by cosine of 37 degrees, I'll get x by itself. X equals 500 cosine of 37 degrees. This time when I type it into the calculator, I'm going to type 500 divided by cosine 37 and hit enter. And I'll see that it rounds to be about 626.07 kilometers. Now here's a little trick. Once you understand how to do these, if x is on the top of the trig function, it's going to be a multiplication problem when you're done. And if x is on the bottom, we'll have a division problem when we're done. Now again, it's kind of a trick. You need to make sure you understand why. If x is on the bottom, we have to multiply both sides by x and then divide by cosine, which is why the trig function here on number 4 ends up on the bottom. Now let's turn our attention to another example here. In the next set, x is no longer a side. Now we're trying to find the missing angle. If we're finding the missing angles and we're using trig, this is going to be a case where we're going to have to use inverse trig. The inverse trigonometric functions are how we're going to undo a trig function. So in this case, I'm going to start by again identifying which pieces I have. If x is my reference angle, I don't have the hypotenuse, so again, this is kind of an indicator of what I'm going to use. I see that the 8 is opposite and the 5 is adjacent. The trig function that has O and A is going to be tangent. Again, anytime you don't have the hypotenuse, you're pretty much using tangent. Now I couldn't use Pythagorean theorem because I'm not finding the side, I'm finding the angle. So in this case, tangent of x equals the opposite, which is 8, over the adjacent 5. So it'll look like this. If I want to solve for x, I'm going to use inverse tangent. So I'll say x equals the inverse tangent of 8/5. Now to do this on the calculator, I'm going to have to use the second function. If you look at your calculator and look above tangent really carefully, you'll see a little tangent with a -1 exponent. Don't call it tan -1. This is called either inverse tangent or arctangent. To find this value, we're going to push second, tangent, and then 8/5. To do the 8/5, you could go 8 divided by 5, or you can use your fraction button and go 8 fraction 5. Either one will work. So let's type it in. Second, tangent, 8, and then either the fraction button or divide, 5, enter. And I'll see that this is an angle that works out to be about 57.99 degrees. Now the reason I'm putting degrees on this is an angle. Our calculator is in degree mode, so we want to show that the angle is also in degrees. So anytime you're solving an angle problem and your calculator is in degree mode, make sure that that answer has degrees on it. For number 6, go ahead and try this one, pause the video, and resume it when you're ready. Hopefully you've had a chance to work this one. Looking at the problem, I now have the hypotenuse. The hypotenuse is 25, and opposite of x is at 18, so 18 is the opposite leg. The trig function that has O and H is sine, so I'll set it up. The sine of x equals opposite over hypotenuse, which in this case is 18 over 25. I'll have to undo the sign by using inverse sine, so x equals the inverse sine of 18/25, and type it on my calculator. Second, sine, 18, and then either the fraction button or divide, 25, enter. And I'll see that x is about 46.05, and because it's an angle, we'll put it in degrees. All right, thank you for watching this video, and I hope it helps you understand how to do the trigonometric functions.